Okay, I'd like to get us kicked off here by welcoming everyone. I'd like to thank you for joining us this morning. I appreciate you all taking the time out of your busy schedules to take part in today's discussion. The goal of today's webinar is to provide you with a best practices overview when planning your upgrade of Windows 10 computers using Symantec's IT Management Suite. I'll present the project approach to take when conducting a migration to Windows 10 and some different options available to you and some important details around each that will help you shape your decision on which approach to take in your environment. In the second part of the webinar, my colleague Matt Green will discuss best practices around building and maintaining a Windows 10 reference image and a walkthrough discussion of a deployment solution imaging job when upgrading from Windows 7 to Windows 10. As always, I'd like to make this presentation as interactive as possible, and I do welcome your input. But in the interest of time management, I'd like you to save your questions until the end of the presentation. At that point, we'll open the floor up for a Q&A session and an open discussion. All right, let's get started. I'd like to start off by introducing myself. My name is Paul Manfredi, and I'm a senior systems engineer here at Intuitive. In the professional services group, I'm based out of Los Angeles and cover accounts nationwide. I've been working with Altiris and now Symantec since late 2006, and have been part of the Intuitive Technology Group professional services team since early 2012. I'm a certified Altiris engineer and instructor, going back to version 6. My main area of focus is the Symantec Endpoint Management Suite, with a particular specialization in ITMS migration and asset management implementations. So a lot of experience around the upgrading and implementing of the platform, as well as working over the years on different migration project types, stretching back to Windows 2000 upgrade deployments. A quick note on Intuitive. We're a national Symantec partner focused in the endpoint management space. We have a very strong dedicated services group. Just a great team of people to work with. As one of the original Altiris partners, just after the company had formed back in the 1990s, So looking at today's agenda, we're going to start off with a migration approach when conducting a Windows 10 migration project. We'll then look at different Windows 10 migration strategies, so in-place upgrades versus re-imaging. We'll look at how to harvest user profiles when conducting a migration of machines and wanting to maintain all that user information and data off of those existing machines. We'll then take a look at the approach to follow when building a hardware independent image. We'll then take a look also at the Windows 10 maintenance basics. So how to keep Windows 10 up to date and how to patch it using Patch Management Solution. I'll then pass it over to Matt, who will go in depth into the Windows 10 image maintenance as well as details. So he's going to discuss things like the VM reference image, how to build it, the process around injecting drivers into your environment, the differences between modular and FAT imaging. He's also going to walk us through the maintenance when it comes to how to maintain your Windows 10 image. And then we're going to wrap up with a walkthrough of a Windows 7 to Windows 10 migration. All right, let's run through a quick overview of some of the key features of deployment solution and the benefits of using it to complete a Windows 10 migration project. So along with being able to provide the tools to migrate the operating system to the latest version of Windows, Deployment Solution also gives us the ability to migrate user data, personality settings, and OS and application settings to the new operating system. This can either be in the form of an in-place upgrade, wipe and reload the existing hardware, or replacement of the new hardware scenarios. So everything from the user's wallpaper to personalized printers, any data that resides locally, as well as all of the operating system settings specific to the user are harvested during the initial steps of the migration process. It also gives the administrator the ability to configure each system on a standardized criteria, such as job function, user type, or physical location. So I can build image deployment jobs specific to a call center department, for example, or different geographical regions where the base image is the same, but specific operating system settings for example, language, data, currency, and so on, are set specific to each region where I deploy. You can also change basic system and network settings during the deployment job. For example, with a task, you can specify the computer name, join it to a specific domain, and provide it with specific network IP ranges. The real value of the tool can be summed up by its ability to reduce the downtime of the client by leveraging the efficiencies of both automated and repeatable deployment tasks. Before diving into the Windows migration project steps, I want to frame the project conversation. And the way different groups will view the project. Managing the expectations of the various stakeholders is a critical part of any project. The main stakeholders during a migration project can be broken down into three basic groups. First is the direct consumer of the service that the migration is benefiting, the end user. The end user's concerns will focus around the final result of the migration. This is the operational result of your test plan and migration procedure. Planning and a constant stream of communication is very important during the migration in order to minimize the potential for failure and to properly level set what is being delivered as opposed to any end user assumptions. Providing detailed project migration schedules, immediate post-migration support, and training is key to the adoption of the new operating system and its ultimate success. The next stakeholder group, and arguably the most important, is the project sponsor. Your C-level executives will need a very different set of information than the end users. So be prepared not only with the technical implementation plan, but a financial breakdown of costs aligned with a specific schedule of the implementation timeline, taking into account various business-specific constraints which may affect your implementation plan, and accurate time estimates of how long each computer being migrated will be out of service. Lastly is the IT department's view of the project. These will be very technical in nature, and we're all aware of them to a degree. Items like ensuring that the implementation plan being proposed is technically feasible in the environment and will not adversely affect any production aspects of the business. All right, so along those same lines of project management, we want to ensure the project planning is thorough. Using these four pillars as guidelines for the migration project will help with the planning phase. First is communication. Build a project communication plan and stick to it. This should include weekly project status calls and bi-weekly project reviews with your project sponsor. Keeping the team and stakeholders informed of progress, status, and any changes to timelines, etc., is critical. Next, set expectations. Clearly define your objectives of the migration. If they change even slightly, be sure to update the team. Set achievable goals. Conduct timeline estimates of your effort involved to migrate one computer, for example, and assign your resources accordingly in your migration schedule. Don't overstretch your migration team or underestimate the efforts involved in the migration. Ensure the end user is aware of their scheduled date and time window for migration of their computer. Next, opportunities. If conducting a wipe and reimage approach to the migration, put time into building a standardized environment. The time invested will surely pay dividends over the lifespan of the computers being migrated through reduced service management requests and increased efficiencies. Make every effort to harvest and consolidate your software licensing. This is the perfect time to take control of software license entitlement and compliance in your environment. Lastly, stay focused. Avoid being pulled into side projects that come up as a result of the migration activities. Be sure that the end users and stakeholders understand the boundary of the migration and what is included as part of the migration budget. Prioritize the easier lines of business to get off to a good start and establish some quick wins. Becoming bogged down in the more complicated business line migrations early on can create the perception of a mismanaged project. Okay, let's walk through now the actual project milestones that we define during a Windows 10 project migration. So from a project management perspective, the approach to a Windows 10 migration will share the fundamental steps that the previous operating system's migrations followed to ensure a successful outcome. The introduction of Windows as a service model has changed the way we need to approach the post-migration day-to-day management and updates maintenance that now follows the new servicing model introduced by Microsoft with that initial Windows 10 release. We'll discuss and explore the key differences later on during Matt's portion of the presentation. If anyone would like the information that details the new servicing model, please feel free to reach out to me by email and I'll forward those links over to you. When we approach a Windows 10 migration project, we typically use the breakdown of the 7 essential steps as a framework of the project and milestones toward its ultimate successful completion. The environment assessment is the first step in the migration. It answers the critical questions like, how many computers will need to be replaced under Windows 10? Or, how many copies of AutoCAD do we have installed versus the number of purchased licenses we own? Begin with collecting both the hardware and software inventories from your environment and begin analyzing the results. Meet with the various lines of business that have specialty hardware or software in order to reassess their needs going forward. Determine the hardware readiness of your environment to create the possible scenarios for upgrade. For example, the number of computers that can be migrated to Windows 10 with an in-place migration versus a reload, or the number that will need additional hardware for the upgrade, the number that will need to be fully replaced, etc. After meeting with the business lines in your environment, build your list of applications that will need to be supported on the Windows 10 desktop. Prioritize the list, making sure to build migration and testing plans for each. Once you have gathered all the hardware information, you know what efforts will be required to go forward with the Windows 10 migration, along with the software application migration plans. It's time to evaluate the cost associated with getting it done. Remember to be mindful of things like internal SLAs to the business lines and re-examine your project plan one last time, looking specifically from a risk management perspective related to your project deliverables. All right, let's take a closer look now at how we derive these hardware asset assessment metrics. There are several tools that we can leverage to assess the hardware readiness of the computers we wish to migrate. They'll help us with key decisions that need to be made early on during the budgetary planning portions of the environment assessment, namely how much the upgrade will cost in required hardware. Once the hardware assessment is complete, you can determine the quantity of computers that meet the requirements for Windows 10 as is, how many will require cost-effective hardware upgrades, such as RAM or hard disk replacement, etc., and how many will need to be replaced outright as part of the migration activities. The two main tools which our team has been using are a custom console report, which is imported into the semantic management console. This report will list out the computers in the environment, detailing the operating system, the service pack level, as well as all the necessary hardware metrics needed to judge whether or not to upgrade or replace it as part of the Windows 10 project. There's also a second tool available directly from Microsoft as part of the Microsoft Assessment and Planning Toolkit for your migration. And I've included a link at the bottom of this slide that points to the download of that tool. Okay, let's take a look at software readiness. So assessing the software is going to be a very similar exercise to the hardware assessment, beginning with collecting the breakdown of computers by operating system in your environment. These metrics will be key early on to help determine the overall complexity of the migration project. Understand what software packages are the most widely used in your environment. It's important to build the priority listing of the software that will become part of the Windows 10 platform, based not only on the sheer numbers of installs, but also, and more importantly, on the criticality of the software from a business perspective. So make sure that when you're meeting with lines of business that you track a metric on the importance of the software to the business line. Determine if any data resides on the user system. For example, home directories, browser favorites, etc. Draft and agree on a policy of responsibility related to user data residing on users' computers, and assist where appropriate. Again, the software assessment we primarily rely on are reports generated in the management console as our primary data source for installed software in the environment. This can be coupled with application metering to build some intelligence into the report and tell us when the application was last used, along with whether it's installed. The next step in our process is to create the standardized Windows 10 build image. The most efficient way to tackle this is by making a hardware-independent image. This type of image will be universal across all of your hardware types, and at a specified point during the imaging process will provide all of the drivers needed by that particular model. We'll look at this a little closer during Matt's walkthrough on upgrading a Windows 7 box to Windows 10. So, once the hardware independent image has been created, it will need to be tested against all of the hardware types that you are targeting for migration in your environment. Essentially, you'll end up with a model-specific directory structure for your particular hardware types, which will contain all of the needed drivers for those machine types. Then, during the imaging process, after the base image has been laid down to the target system, we use a VB script task to determine the specific model type and inject the required drivers into that machine's image. After you've certified that the imaging process is functioning against all of the supported hardware models, you'll need to determine which software applications to include in the base image, as opposed to which ones will be delivered through software delivery policies after the system has been imaged. Typically, we keep the base image as lean as possible, adding only security type applications like antivirus protection apps, as well as a clean semantic management agent install. Here's a graphic to help explain how the hardware-independent imaging model works. So, hardware-independent imagings, or HIIs as they're referred to, enable your organization to capture one operating system image and later deploy the same image to multiple machine makes and models across the organization. This is accomplished by first capturing an image that is generic and as light on drivers as possible. This image is then deployed to other computers using drivers specific to the hardware injected as part of the process. Again, Matt will go through this and the specific steps around building that hardware-independent image using a virtual environment a little later on in the presentation. So many organizations would previously have had one operating system image captured for every unique make or model of computers in use. This approach took an exponential amount of effort and disk space when compared to the hardware-independent solutions we use in IT Management Suite. Hardware-independent OS deployment solutions have also existed in previous versions of the ITMS Suite. However, with recent enhancements in the 8.1 platform, such as driver tagging, we can more precisely control which drivers are installed for a given model. Symantec has developed driver tagging to specifically address the needs of newer UEFI devices with increasingly unique and challenging driver requirements. So the next step in our migration project is the preparation of the software applications. This can be a particularly difficult phase of the project to manage, depending on the number of applications currently running in your environment. A holistic approach should be taken when looking at the software applications and how they will impact the Windows 10 migration project overall. Defining the scope of applications that will be included as part of the migration is the first step. An important prerequisite to this step is having a complete listing of all software currently installed and being used in the environment. Again, this can be collected through a combination of the software inventory reports as well as application metering reports. These reports will provide important metrics not only on the software titles, but more importantly, if and when they are being used. Aggregating that data and having it be part of your meetings with the various lines of business to discuss their core applications and how they relate to the migration will be key to the overall project success. Again, these reports will also help you boil off all of the unused and unneeded software that will also save both effort to integrate and money on license renewals. So once you have your definitive list of software needed in your environment, you'll need to ensure that the versions you own are supported by Windows 10. Depending on the results of those findings, you may need to upgrade some existing software application versions prior to your migration or as part of it. Again, this will need to be tackled on an individual software application basis, taking into account factors like the cost of the application, the criticality of the application to the business, possibility of replacing the application with a different one, etc. So, a lot to think about when it comes to the roadmap for software applications in your environment when moving to a new operating system. After you have your list of applications that will need to be supported on your new Windows 10 systems, a test plan should be drafted to ensure that they will all play nice together. We typically build out a plan based on lines of business and software applications needed by each one of them. Once the compatibility tests are complete, you'll need to start repackaging activities of those software applications so they'll be ready to be used as a software delivery task to install them during the imaging job on the migrated Windows 10 systems. You'll need to take note of any custom install requirements when repackaging and test them thoroughly again. So by the end of this phase, all of your in-scope software applications should fully be tested, repackaged, and ready to be added to a policy or task as part of your imaging process. After completing the software application preparation work, the next step is going to be creating a strategy and process for harvesting the existing user data and profile information from the user's existing system as part of the migration. This step will not need to be performed where you're conducting an in-place upgrade to Windows 10, as it will keep all the existing settings as part of the upgrade process. However, it will need to be done when moving to a different system as part of the migration. Deployment solution, which is an integral part of the ITMS platform, lets you capture all of the user's profile and settings from their system, which we refer to as the user's computer personality, as a pre-imaging task. Information like the user's individual files and folders, application menu bars, settings like desktop, control panel, display, and networking properties are also available to be captured. The built-in feature is called PC Transplant, and using it, you're able to generate a template to define the information that will be captured in the personality package. This task can be integrated into your reimaging job, which lets you both automate the capture of the personality and, after the reimaging is complete, lets you restore the personality back to the system. Because of the amount and type of data, it can vary considerably between users. You'll need to clearly define and communicate what exactly will be included as part of the personality capture process. One caveat to keep in mind when using PC Transplant is when you use the built-in job that will capture the personality to a local site server. We typically configure it to copy the personalities to a centralized location to minimize bandwidth considerations. Again, this will vary depending on the bandwidth in your environment between sites. All right, let's move on to the next step. So after you've completed the build of all of the specific tasks we've looked at for your migration, it's time to assemble them into an imaging job in the Semantic Management Console. So your systems at this point have been identified for migration. Any required hardware upgrades have been completed on them. Your software application packages are built and tested. And you have your PC Transplant templates ready and tested also. I recommend at this point a build schedule, again, be created ahead of time. This schedule would list not only the target migration date and user sign-off of a completed system migration, but also an area where you would track the installation status of any hardware prerequisites, a listing of the software applications needed, as well as the details around user-specific data capture requirements for PC transplant. This schedule would also list the user's department and the specific imaging job that will be used during the system's migration. Once we have those aspects defined, we're able to assemble a tailored imaging job in the console. We typically create specific jobs based on a common criteria, for instance, by department being migrated. This way, all of the common features can be targeted to a specific group of systems. For example, the finance department will have software applications which are specific to their department. So the finance-specific imaging job will include a software installation task with those specific apps. Moving through your migration project by department is probably the easiest and most streamlined approach. One point also worth mentioning here is the phased approach which should be followed. Like with any project where you will want to pilot out the newly migrated image to a few prearranged users from each department and work closely with them to fine-tune the final imaging job before you roll it out during the full migration. So, at the end of this project phase, your image is assembled and automated, ready to be tested as a complete imaging job from Deployment Solution. All right, now that the imaging jobs are automated and assembled, they're ready to be tested. The first phase testing should take place in your lab environment. It should encompass a mock migration using your build process of at least one system for each of the departments that has been scheduled for migration. Any and all issues you run into here should be documented and remediated before going any further. Once the testing is complete, your scheduled pilot systems should be done next. Remember, this is a few selected users from each of the departments that you are migrating. You will need the resulting feedback before going forward with your production phase of migration. We usually use a detailed pilot implementation schedule, making sure that the help desk and user support teams are kept up to date on the pilot migration schedule and are copied on all communications to end users regarding their system's migration. Working closely with your early adopters is one of the best ways to gather quality feedback on the technical aspects, as well as the overall end user experience of migrating their system. After the pilot deployment is complete, we typically let pilot users take at least 1 to 2 weeks of usage of their systems while gathering feedback. Once feedback has been collected and any minor changes or issues remediated, we turn our focus to the production migration. Again, here, we leverage a migration schedule based on departments, along with a detailed communication plan. It begins with a confirmation with the end user of their actual migration time window and ends with a sign-off that all of the application and data checks have been completed successfully. This information is then filtered up and becomes part of the various project status reports that will be submitted to management and during our status reports. Speaking of those status reports, a key aspect to any successful migration project is the ability to report and measure on progress. Being able to identify the total number of migrated systems based on a migration schedule is essential. with details like end user, department, type of migration, if the system was being replaced, etc. The planned migration and the actual migration date are also helpful in determining if our project is trending close to the initial project estimates. Any unforeseen problems need to be reported immediately during the migration. Team members will need to track an issue to escalate it if necessary, if it cannot be remediated during the migration itself. Again here, leverage both console reports and the migration plan tracking spreadsheets as a source of metrics to provide to management during the project status calls. These should be updated and reported on weekly, if not daily, during the production deployment phase of the project. Project sponsor confidence needs to be maintained, and the best way to do that is with positive numbers. Okay, we're going to change gears here and now look at the different Windows 10 migration strategies when approaching our Windows 10 migration project. So, different migration approaches to migrating systems in the environment. We typically encounter one of the three following approaches when conducting a migration project. First off, on the left is the mass migration. This type of approach will essentially be an outright replacement of all of the systems in the environment to Windows 10. All the systems are built on a small number of new hardware models. It ensures that all of the environment is running on a common platform, which also makes management of those systems a lot easier. But realistically speaking, unless all or nearly all of the systems are due to be replaced, this is a very expensive option, and we rarely see it in larger environments. The second approach is called batch migration. This approach will maintain several sets of configuration standards, usually depending on the usable life left in the models being managed in the environment. So we'll end up seeing a mixture of some new hardware, along with reimaging and in-place upgrades of existing systems. This is probably the best combination of manageability and cost compromise because the existing environment is leveraged where possible to Windows 10 while providing those hardware cost savings. The third approach, which can be followed, is the gradual migration. In this approach, Windows 10 is integrated into the environment based solely on the hardware asset refresh schedule. That means when a user system is due for refresh based on its end of service life date, it will be replaced with a Windows 10 system. This approach is less of a project and more of a switch to a new operating system as part of the end of life of the hardware asset itself. The obvious advantage here is the upfront savings because there is no hardware expense that wasn't already planned as part of the normal operational costs. The downside, however, is the possible creation of a management nightmare where supporting multiple standards and operating systems is drawn out far longer than it should be. Okay, let's take a look at the differences now between an in-place upgrade and a wipe and reimage. So first off, an overview of the in-place upgrade. When migrating to Windows 10, you can either perform a wipe and reload reimaging process or simply update the operating system in place without performing any imaging. Again, we'll discuss when to choose one method over another in a little more detail during Matt's walkthrough portion. As we saw in the previous slide, you may need to use both strategies in your organization. In order to perform an in-place upgrade, you'll need the Windows 10 ISO file. It should be deployed using a managed software delivery policy job prior to the upgrade process. This will give you better management and reporting on systems that have the update and those that don't. As far as benefits go, in-place upgrades can make it easier to upgrade the operating system as it retains all the content on the computer. Also, a standard OS image is used. After the upgrade completes, the entire user profile is maintained, keeping all the settings as they were prior to the upgrade. Being a more simplistic approach, the upfront testing may also be reduced, as well as the deployment preparation compared to a wipe and reload scenario. There's also a rollback option available in the event that an upgrade is not successful. As far as drawbacks go for an in-place upgrade, there can be compatibility issues related to third-party disk encryption tools if they are in use. We've seen those. Although there is native support for Microsoft BitLocker, others, like our Symantec endpoint encryption, will require a workaround. And if you notice in the slide during that bullet point, I do have it pointed to the KB how-to article. Again, anyone needing any further information on that, please feel free to reach out to me by email. So application compatibility is also a critical, important piece to consider here. It's entirely possible unknown applications have compatibility issues, and they'll only arise after the upgrade to Windows 10. So every application must be compatible with Windows 10 after the upgrade. Otherwise, you may find yourself with applications that don't work and need to be cleaned up manually. In worst cases, you may find the machine won't boot after the upgrade. A wipe and reload here can often be a good fit when application incompatibilities block that clean in-place upgrade path because of the application upgrades can be achieved simultaneously using the wipe and reload option. Okay, moving to the overview of wipe and reimage option to follow. For a complete reimage to occur, there must be a fully captured and custom image. So, as we spoke about earlier, you'll need to create a standard build or gold image. Whether this is a thin, thick, or hybrid image approach is entirely up to the organization's needs. At a minimum, though, drivers are needed to complete the pre-boot loading of the OS and post-image process for keyboards, language packs, video, etc., specific to the computer model type being reimaged. Looking at the benefits, the first major benefit to a reimage approach is the fact that you can create a full image. It can be used to image a bare metal system. With the reimage, you can also provide a fully standardized system standard to the environment, or specific standards based on the role of the computer and the role it's playing in your environment. Also, the department using the system, or the location where the system resides. So a lot of flexibility in the standards you're able to build during the reimage process. Also, any BIOS changes can be taken care of with a task during the reimage of the system as well. Any application upgrades can be packed in with the supported versions and set as subsequent tasks or software delivery policies following the reimage job. Looking at the drawbacks, the major drawback to the reimage scenario is the fact that when a system reimage is performed, none of the user data is preserved by default. Again, a tool such as PC Transplant, which is included with deployment solution, must be utilized to ensure the user data is captured and deployed to the newly imaged systems. Also, any custom device drivers that are required must be installed on the machine using the device driver injection method. Whatever applications are required by the end user must either be included in the image or will need to be reinstalled after the reimage process is completed by task management again or a managed software delivery policy. This will require the creation and maintenance of software packages for the required software applications. All right, let's look at some basics around maintaining our Windows 10 image after it's been imaged and the imaging process is complete. So keeping our Windows 10 image up to date. Once we have our environment migrated to Windows 10, our next order of business is keeping the clients up to date. Let's look at the strategy to do this and the key differences between Windows 10 updates and previous versions of Windows. So Windows 10 as a service. Looking at Windows 10 and how it compares to the previous versions of Windows is significant. Prior to Windows 10, Microsoft released new versions of Windows every few years. This method of updating their operating systems imposed a training burden on users because the feature revisions between Windows versions were often significant. So there was an extended learning curve moving to a new OS. That type of release schedule also meant waiting long periods of time before those new features became available. Windows as a Service hopes to deliver smaller feature updates roughly twice per year. They've slated it around the March and September timeframes to help address the issues I just mentioned. The first type of update is the feature update. And the feature update is the update available, this first type called the feature update. With Windows 10, Microsoft packages new features into feature updates that can be deployed using Altiris Patch Management Solution. Because feature updates are delivered more frequently than with the previous versions of Windows, which again around twice a year, rather than every 3 to 5 years, changes will need to be handled in bite-sized chunks rather than that all at once, and end user readiness time will shorten accordingly. The next type of update delivered by Microsoft is called the quality update. This is the more traditional type of monthly updates we're used to with previous versions of Windows. They can often be overwhelming because of the sheer number of updates available each month. In our experience, we've seen many organizations selectively choose which updates they wanted to install and which they didn't. And this created countless scenarios in which organizations deployed essential security updates, but picked only a subset of non-security fixes. In Windows 10, rather than receiving several updates each month and trying to figure out which the organization needs, which ultimately causes platform fragmentation and a divergence away from that standard we referred to, we'll see one cumulative monthly update that supersedes the previous month's update, containing both security and non-security fixes. This approach makes patching simpler and ensures that customers' devices are more closely aligned with the testing done, therefore reducing unexpected issues resulting from patching. I put up a visual representation of the Windows 10 lifecycle or proposed lifecycle support end dates. So as you can see in this graphic, there are already two versions of Windows 10 1507 and 1511 that have already passed their end of support dates. Again, this is in line with Microsoft's strategy of the Windows as a service model, whereby the feature updates essentially replace the previous version of Windows. Again, the ultimate goal here is that each version has a lifespan of roughly 6 months before the next feature update is released and deployed. This is a dramatic shift from earlier versions of Windows service packs, and will require more frequent efforts to schedule, test, and deploy the feature updates. So please keep this in mind when building out your Windows 10 lifecycle plan. So let's look at the patch management and how we use patch management solution when updating Windows 10. So as you may already know, patch management solution detects Windows devices that require cumulative updates, feature updates, monthly quality roll-ups, or monthly security updates for Windows 10. It also provides us with the tool set to install and manage those updates, and also track the updates installation progress and provide compliance reports based on the success and failure of those updates. These Windows 10 update features are fully supported in the ITMS platform, and they have been reaching back to, I believe it's SMP version 7.6, hotfix 4. For smaller corporate sites where large file sizes are an issue because of the lack of an on-site package server, one of the enhancements in the 8.1 version of patch management is it now supports data transfer efficiencies, which leverage multicasting and peer-to-peer package download capabilities. Both solutions let devices download packages from other devices at their site rather than reaching across the WAN to the notification server or the package server, which can greatly impact the bandwidth between sites. The platform is also supporting both monthly Delta and cumulative updates. Windows 10 monthly update package is a smaller file that contains only fixes for the selected month. The Delta updates are applicable to the computers that have cumulative or Delta updates installed for the previous month. Then there's the Windows 10 monthly cumulative update package. This is a large file that grows each month because it contains all the fixes, not only for the selected month, but also of the previous months. The cumulative updates are applicable to the computers that do not have cumulative or Delta updates installed for the previous month. A couple of caveats worth mentioning here. Firstly, that monthly Delta update package, they're only available on Windows 10 versions starting from the anniversary edition of 1607. This is actually the last or oldest supported version of Windows 10 and that we saw in the previous slide. The second caveat is that the client systems should have their Windows Update service set to manual for the software update cycle to finish successfully. We've seen in certain circumstances, if it's set to automatic, the machine will hang or it'll reboot inadvertently. Again, this is to stop that client from updating outside of patch management solution by using Windows Update. All right, at this point, I'm going to pause the presentation and pass it over to my colleague, Matt Green. And Matt's going to go through more detailed explanation of things like the reference image and the imaging process. Thank you very much.